Remember, if you want to do Wi-Fi, don't remove this USB header. Either do the external modification or keep everything as is with the Wi-Fi module on board. These next steps, and you don't have to follow this, are only for the optional Ethernet mod. That is where we take a USB to Ethernet 10 and 100 megabyte per second adapter, and we will cut off the end here and then solder it directly to the pins on board. And just for your information, do not get the one that is labeled OTG. Those are specifically made to attach to your phones, and other smaller devices that use the OTG connector use one that is meant for USB 2.0 or 3.0 to connect here, even though this USB jack is only USB 2.0. So this is fairly cheap and easy to get, and also make sure that it is this style of form factor. You'll see when we open this up that it's very small, and that's what we want. So this is the very cringe part, and I know a lot of you are probably going to be yelling at the screen, but this is the way that we've managed to do a lot of our boards in the past. And also the reason why we're doing it this way too is we understand that this top plate, or this top pad, is also a ground plane. So even if we scratch it, it's not like it's going to bridge any of the connectors going through here. There's a lot of space in between where if we do scratch the top surface, that it's not going to cause an issue. So I'm going to be careful around these capacitors to not chip them away. It's probably better to remove the outer casing at this point. So that should pop right off. And then you can slide over the top here. Be careful, these things can be sharp. Now again, this is the preferred way we do this. However, there are other ways that are more suited to not destroying the board. But we find that this method still suffices. What we're trying to do is basically decase the USB header little by little, not putting too much stress on the board. So once we're at this point, this is where you can kind of move parts back and forth, and it'll fatigue off. And remember, these things are sharp. So either have very calloused hands or use protection. And this is the last part. This is the more important part to make sure you don't cut through anything. You want to just gently go back and forward until it finally breaks. And you can tell when it's a lot less resistance, that it's starting to get to that point. There you go. And even if there's a little straggler like this one right here, you can come in afterwards and take your flush cutters and just snip that last one off. So there you go. Now, this is a good point to take your voltmeter, and if you have a continuity check, this is only if you feel like you've accidentally cut a trace or if you've bridged a trace, because as you can see here, I've accidentally gouged a line through this trace right here, and this is generally the 5-volt line that goes into your USB port. So what we want to make sure is that this right here, this exposed part, or this one, which are generally ground, you want to make sure that they did not bridge themselves. And what you can do is, with one like this, they have sound, and if they bridged, then you can actually hear the sound. At which point, we would recommend you either using a new one or figuring out what you did and making sure that you undo that. So we're just going to make sure that there isn't any other piece of metal that happens to be bridged around here, and that might give a false positive result. So we're just going to put and it doesn't really matter. You could either be this way or this way. You're going to put one of the leads on the ground plane. You're going to put the other one over on the 5-volt. Now, if you heard a little chirp, a lot of times that's just the power going through the regulator, either clearing out some of the capacitors or some of the other components. You just want to make sure that, see, like these are all ground planes here, but this one right here, I'm not getting any reading. So that means my 5-volt is pretty much separated from the ground plane, which is what you want. And then what we can do is we can check some of the other ones. See, if you were actually going to get a reading here, or a resistance reading, see, like right there, and a long beep, that would mean that it's bridged, and that these two lines are connected. But if you got the chirp and 0 readings here, or your overload setting, and it's a good indication that you have not bridged anything. So I'll actually just hold it here for a while, and nothing. So in the next segment, we are going to perform the Ethernet mod, and we will connect the two together. This next step will require you to have some solder and your soldering iron. So this next step, and the main reason why we want to get it this way, is, as you can see with these 3D printed materials here, this gets you the cleanest way of going from point A to point B. Now, there is a bit of room underneath the bottom right here where you can get your lines from here. So if you wanted to solder on this side, that's still fine. But for what we're going to show you, we're going to do it from the top side. So first things first, you need to decase the USB to Ethernet connector. You can do this a couple ways. If you're brave enough, you can use your fingernail, and you're trying to go along the edges here to pop some of the locks. Now, if you want to make your life easier, you can just take your flush cutters, and you can kind of get in between here, and you can pop it off that way. Just be careful not to go too far, because there is still circuit board. Now, we don't care about the case, so really, if it breaks, that's fine. Now, the circuit board, on the other hand, that's important to us. So as you can see here, the circuit board has a couple of wires coming off of it with some hot glue covering over the top of it, typical QC pass, and then the connector on the top. Now, these two components are the main ones, and those are the important ones that we want to worry about. Now, the next step here is we're going to cut the line at the very, very end point here. I mean, you can even cut it even further if you feel like you need more cable. But for what we're going to do, we're going to cut this off, We're going to move some of the sheathing back, because there's actually 4 wires that you can see right here on the inside of this. And we will need to strip the wire back in order to get at them. Now, we need to just remove that tag, because we don't care about where to download the drivers. This one in particular is natively supported by the Raspberry Pi, so as soon as you plug it in, it's good. Now, this is another optional tool. We didn't talk about this in the beginning, but if you happen to have some wire strippers, that's where this comes in handy. Now, you just need to get the appropriate size, and you want to strip a lot of this off. So that wasn't the right one. So probably about 2 millimeters. Yeah. And then you pop that off. Now, sometimes you get a little too excited and you strip off one of these wires. Don't worry. That's why we suggested using some of the actual cabling here in the beginning. You can solder on an extra one. We prefer if you would keep the color codes the same. So in this case, I broke the green wire, so I'd want to add the green wire back on. But once you do that, you can then strip the wire back and add it on here. Now, you can see the board orientation on how it is. The color code is the same on pretty much all USB devices, assuming they all follow the standard. Black is ground, red is positive 5 volts, and then white and green are generally reserved for TX and RX. On the actual Raspberry Pi, remember how I pointed out that this one in particular was 5 volts and this one over here was ground? So it would go from down here to up here, red, white, green, and black. So at that point, you would just strip all the wires back, solder these two together, and you should be done. So with your soldering iron in hand and some solder here, the PVC sheathing can actually be removed using heat. You don't necessarily have to use your wire strippers to actually bring it back. Just make sure that you're using a very hot iron, a little bit of solder, to pre-tin these wires. And once you're done, then you want to pre-tin these pads as well. Now, this is important. This is where you probably want to increase the temperature a little bit. We're going to increase our temperature to about 650 to 700 degrees Fahrenheit on our soldering iron. And the reason being is, not only is this a large ground plane, so a lot of the heat is just going to disperse all over the place, but they're using some pretty intense non-leaded solder here. So we're just going to try to make sure that we not only do the two small ones very fast, because these trace lines are very, very small and can be easily lifted with a lot of heat. Same thing with the 5-volt one, but it's also so that we can get enough heat into the ground plane. Now, we suggest doing the ground one first, because what this is going to do is it's going to pretty much preheat the pads around it. It would be beneficial if you owned a board warmer, which is a device that basically just blows and heats up your board. Pretty much preheats it to just a bit below the melting point of the solder, and it just makes it easier to reflow solder or to move components around if need be. So I'm just going to add a little bit of solder here. You can see it's kind of sticking. That is a sign of not enough heat in the area. Now we can keep adding it to the iron here, but you can see it still sticks whenever we touch the actual point where the copper is on here. And the reason why that is the board is still trying to heat up. It's soaking all of that heat into the ground plane all over the place. Generally speaking, ground planes are pretty much the worst to solder onto because they act like giant heat sinks. Once you get to a point where you actually feel pretty good, and you add enough here and it soaks in, then you can move on to the others. Yeah, that should be good enough. So we're going to do the 5-volt one next. You're basically just going to hold your iron here. And you can kind of pull it apart to see how well it's just going to adhere to the top. Now this one, again, also requires a lot of heat just because of the solder, the non-leaded solder, but it looks like there should be enough for it to just stay there. Now we're going to do these ones pretty quickly. They don't take a lot of heat because there's not actually a lot of material there. So once that's done, you have your contact points to do. Now, remember the color code. It goes red, white, green, and then black. So we're going to take our red lead first. Now, this is sort of a, you don't have to do it this way. I just happen to be right-handed, and it's a little easier to actually come in from this side to solder without getting in any of these components. So we're just going to heat up that point here, and we're just going to attach the red. We're going to pull away. We're going to wait a little bit so it cools down. If it's too hot, generally what happens if you pull it away, it actually will come out with it. And then we will do the other ones, starting with the white and then the green. Now, if you didn't sheath it back far enough and you have a little bit of wire to work with, we would suggest using a pair of tweezers and holding this down here and then soldering this together. But if you're fine with that, you can actually go in and do this by hand. So again, we're going to heat up the area, and we're just going to touch the two together and done. Because remember, these ones are the quick ones. We don't want to stay too long. Staying too long at a high temperature will have a higher chance of flipping the pad up, and the whole trace line can actually delaminate from the board. We don't want that. So the next point here. This one's a little more difficult because this is the ground plane, but since we use some of the solder up on top, this might not be so bad. And once that's set, make sure you pull that apart, and you're done. So a couple ways to test this. We will actually go through this later on, but when you first start up the Pi and you connect this to your router or switch or whatever connectivity you want to connect it up to, you'll notice that there are two lights here, and that shows the connection on board. If you've done this right and you haven't bridged anything and it's getting the appropriate power, those lights should illuminate and one of them will start to flash, indicating a data transfer. So if you really wanted to be safe, because you can see these are very fine wires and you don't want anything to come into contact with this, I would suggest taking a hot glue gun, and just like they've done over here on the actual module itself, you want to just lay down a nice bead over the top here, because at this point this is done. This connection right here will ensure that it has a nice sort of place for us to put the actual connector on the ends of the case itself, and we won't have to use any of these other connectors once we solder the actual board on. So the next video we will actually prepare this board. We will go through and configure pretty much the only solder pad the jumper right here that you would actually have to do. You either choose GPIO 10, GPIO 18. We will put the lithium cell here, and we will put the connectors on for the fan. Along with, if you've bought the optional BME 280 sensor, we will also cut that to length, and we will put that in the right spot.